Welcome back to the Solutions Manual. In this video, we will solve the problem 5-13 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the reactions at the supports. So to solve this problem, first of all, we have to draw the free body diagram. So the point A is the roller support. So we just have a vertical support reaction. The point B is pin supported. So we have a vertical as well as the horizontal support reaction. Let's label them. So this right here is AY, this is BX, and this is BY. Now we have to find the resultant of this distributed loading. So we will resolve this distributed loading into a rectangle and a triangle. Now for the resultant of the rectangular distributed loading, let's call this FR1. It is equal to the area of this rectangle, which is the height, which is 600 newtons per meter, into the base of this rectangle, which is 3 plus 3, 6 meters. So the resultant of the rectangular distributed loading is 3600 newtons. And it will act in the middle. So this is FR1, which is 3600 newtons. Now we have to find the resultant of this triangular distributed loading. So if I draw it separately, then it would look something like this. The base of the triangle is 3 meters and the height of the triangle is 900 minus 600 newtons per meter, so 300 newtons per meter. So let's call the resultant of the triangular distributed loading as FR2. It is also equals to the area of this triangle. So we have 1 upon 2, the base, which is 3, into the height, which is 300. So upon simplification, the resultant of the triangular distributed loading comes out to be 450 newtons. And now for the location of FR2. So it is equals to 1/3 of base from thicker end So this is the thicker end of the triangle. So we have 1/3 of base. The base is 3 meters. So FR2 is located 1 meters from the thicker end. On the free body diagram, it would look something like this. This is FR2. And it is 1 meters from the thicker end. So this is our free body diagram. Now we can apply our equations of equilibrium. So my first equation is sum of moments about point B equals to 0. I am considering counterclockwise direction as positive. Since the line of action of Bx and By is passing through the point B, so these two forces do not have any momentum with respect to the point B. So Bx and By will not produce any moment. about the point B. This 3600 Newton force is trying to rotate the beam in counterclockwise direction about the point B. So the moment produced by this 3600 Newton force will be taken as positive. So we have 3600 and the moment arm is 3 meters. This 450 Newton force is also trying to rotate the beam in counterclockwise direction about the point B. So the moment produced by this 450 Newton force will be taken as positive. So we have positive 450 and the moment arm is 3 plus 2 meters. So 5 meters. The support reaction AY is trying to rotate the beam in clockwise direction about the point B. So the moment produced by this support reaction AY will be taken as negative. So we have negative AY and the moment arm is 6 meters equals to 0. So upon simplification, we have 10,800 plus 2,250 minus 6AY equals to 0. So AY comes out to be 2,175 newtons. So this is our first answer. Now for the support reaction Bx, we can do sum of the forces in x direction equals to 0. I am considering right hand side as positive. Since we have only a single horizontal force, which is the support reaction Bx, so Bx is equals to 0. This is our second answer. Now for the support reaction By, we can do sum of the forces in y direction equals to 0. I am considering up direction as positive. So we have Ay plus By minus 3600 newtons and minus 450 newtons equals to 0. So Ay is 2175 plus By. If you combine these two, it becomes 4050 equals to 0. So upon simplification, By comes out to be 1875 newtons. So this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the free body diagram or in the equations of equilibrium, then feel free to ask in the comment section and I will try to answer them as soon as possible. Thank you.